Good day guys, welcome back to Wiki Science YouTube channel. In this video, I'll be putting you guys through radioactive radiations as well as knowing the difference between these radiations, also being able to balance a nuclear equation that occur during nuclear reaction. Okay, let's get to it class. Now, the radioactive radiations are those radiations or particles emitted during nuclear reactions by a radioactive element, and this is due to the fact that radioactive elements, they have their nucleus to be unstable. The instability is determined by the ratio of proton to neutron. So the difference that occur between the proton to neutron ratio is actually responsible for these radioactive elements to become unstable and therefore release radioactive particles or radioactive radiations. What are these radiations? There we have what referred to as the alpha particle, we have the beta particle, and we have the gamma ray. During the emission of this gamma ray, there is always some certain amount of X-ray that can be produced in this case. Now, there are some certain amount of X-ray that can be produced along with gamma ray. This is due to the fact that the gamma ray is having higher frequency than the X-ray, and the wavelength is shorter than that of X-ray. So during the process in which gamma ray is produced, X-ray can be produced alongside with it. Okay, now let's look at the difference that occur among this radiation. Let's take it one after the other. The first one now is alpha particle. We have the alpha particle. Let's look at the feature of the alpha particle. The first thing I want you to know is that the alpha particle exists as helium nucleus. It does exist as helium nucleus, having the atomic mass to be 4 and the atomic number is said to be 2. Aside from this, the alpha particle is said to be massive. So it is massive. And this nature of alpha particle being massive is responsible for the fact that it will be having higher ionization energy. So it therefore has high ionization energy. Ionization energy. What is the ionization energy? The ionization energy is the energy required to cause an atom to lose electron such that the atom becomes an ion. So that's what referred to as the ionization energy. And due to the fact that it is very massive, it will not be able to penetrate through lattice. Instead, it will cause the atom that make up the lattice to form an ion. So as a result of that now, it can also cause zinc sulfide to fluoresize, and in this case now, it can cause fluorescence of zinc sulfide. Why? Due to the fact that it cannot penetrate. So it has a fluorescence action on zinc sulfide. As also, I want you to know in this case now that due to the massive nature, it has low tendency of penetrating through molecules, of penetrating through lattice. So this tendency of penetrating through lattice is called referred to as penetrating power. So therefore we say that it has low penetrating power. Okay, it has low penetrating power. Also in this case, it can be deflected by electric field and magnetic field. But how can it be deflected by electric field and magnetic field? So we need to look at the charge. Okay, it is positively charged. So we need to take note of that. It is positively charged. And the magnitude of this charge is twice that of electron. So it is positively charged. Now this positive charge, according to electrostatic law, which states that unlike charges they attract while like charges they repel. So in this case now, it will be attracted by a negative charge. So in this case now, what are the negative charge? Let's look at it in the case of electric field. If electric field is placed close to beta particle, it will be deflected by the negative pole. It will be deflected by negative pole of an electric charge. And if it is in case of magnetic field now, if it is in case of magnetic field, it will be deflected by the south pole. It will be deflected by south pole. Now, another thing which I need you to know in this aspect is that the speed is relatively small to the speed of light. It is relatively small to the speed of light. That is, moves at a speed less than the speed of light. Speed is less than speed of light. And what's the speed of light? That's why we have 3 times 10 to the power 8 meter per second. 3 times 10 to the power 8 meter per second. Now let's compare this alpha particle with the beta particle now. Let's compare it with the beta particle. When we compare it to the beta particle, we realize that this one is an high energy electron. Beta particle is an high energy electron. It's an high energy electron. Compared with the size, the mass. In comparison with the mass, it is moderately massive. Let's just put moderately. Moderately, not highly. This one is highly massive. It is highly massive. Let's change this to highly massive. So I can put here moderately massive. So it's moderately massive. Now in this case now, the ionization energy is also moderate, not as high as the particle. So here we have moderate ionization energy. It has moderate ionization energy. Now let's now consider the fluorescence. Due to the fact that the ionization energy is moderate, it cannot significantly cause fluorescence of zinc sulfide. So it cannot cause the fluorescence. So it does not cause fluorescence because of it cannot cause fluorescence of zinc sulfide. Now let's look at the penetrating power. In terms of the penetrating power now, the penetrating power is said to be moderate in this sense. The penetrating power is higher than that of alpha particle because the mass is smaller than the mass of alpha particle. So the penetrating power is high, or let me say moderate. Moderate penetrating power. It has moderate penetrating power. Now let's consider it with the charge. Here we say the alpha particle is positively charged, but here the beta particle is negatively charged. And when you talk about the deflection now, in this case now, since it is negatively charged, it will only be deflected by a positive pole. In electric field. Positive pole of electric field. It can only be deflected by positive pole of the electric field because it is negatively charged. Now we also talk about the deflection with the magnet. If it is with respect to the magnetic field now, it will be deflected by the north pole of magnet. It can be deflected by north pole of magnet. Let's consider the speed. Because this is high energy electron, and since electron moves at relative speed, that is a close speed with the speed of light, then we say that it moves at approximately speed of light. It moves at approximate speed of light. Another thing which I want you to concentrate your mind on here is that if assume this is a sheet of paper now, if this is assumed to be a sheet of paper, this alpha particle cannot penetrate in it will be deflected back. But when we compare it with beta particle will penetrate through this sheet of paper because of the mass is lesser than that of alpha particle. So it means that ordinary sheet of paper can be used to stop alpha particle, but beta particle will penetrate through the sheet of paper and it can only be stopped by aluminum sheet. Okay. Now let's look at the gamma ray now. In the case of gamma ray is an electromagnetic ray. Is an electromagnetic ray. So the nature of gamma ray is electromagnetic in nature. It's one of the electromagnetic ray with very high frequency and short, in fact the shortest wavelength. Now in this case, now we move to the mass. With respect to alpha particle, beta particle, you realize that the gamma ray is having negligible mass. That is, the mass is so minute, the mass is so small that it cannot even cause ionization. So the ionization here is low ionization. It has low ionization energy. It only has low ionization energy. And because of this low ionization energy, it cannot cause fluorescence. It cannot cause fluorescence. It cannot cause fluorescence. It cannot cause fluorescence. Now let's move to the penetrating power. Because the mass is very minute, it can easily penetrate through lattice of atom. So we say it is having high penetrating power. It's having high penetrating power. High penetrating power. In fact, it is having the highest penetrating power with respect to alpha particle and beta particle. Now let's look at the charge. It has no charge. In this case now, it has no charge. It has no charge. So if it therefore said to have no charge, then definitely it cannot be deflected by electric field. It cannot be deflected by magnetic field. However, it can move at the speed of light. So it moves at speed of light because all the electromagnetic radiation, they move with respect to the speed of light. So it moves at speed of light. Now, with respect to alpha particle, beta particle and gamma ray, I said that alpha particle can only be stopped by ordinary sheet of paper. When it comes to beta particle, it can be stopped by aluminum sheet. But when it comes to case of gamma ray can only be stopped by lead block. It can only be stopped by lead block. That's to show the degree of its penetrating power. But when it comes to the case of alpha particle, ordinary sheet of paper can stop it. Now, I believe we understand the difference that exists and why those differences occur among alpha particle, beta particle, and gamma ray. Now we move to the aspect whereby we look at how these radiations can be emitted in a nuclear reaction when they are represented with a nuclear equation. Even if they are unknown in the nuclear equation, we'll be able to distinguish which particular radiation is emitted. So now let's look at that now. Now let's consider this question taken from WAEC past question 2014, question 12C. This theory aspect. Now the question shows equations, equation A and equation B. Here we have random and it is 222 and it's having P. What you have up here, shown up here, is the atomic mass. And what you have shown down here is the atomic number. So here the atomic mass is 222 and the atomic number is P. Atomic mass is 218 for polonium and the atomic number is 84. And here you have your helium nucleus and you have Q. Now to balance it, what we always do is that the total of the atomic masses for the right hand side must be equal for the left hand side. the one you have on the right hand side must be equal to the left hand side. Here now, this is 222, and here you have 218, and here you have Q, meaning that the atomic mass here plus the atomic mass here must give us this 222. So to get our Q now, we can simply say that Q is equal to 222 minus 218, and that will give us 4. So 4 plus 218 will give me 222. So here we have the value of Q to be 4. We are done with that. For P now, in order to determine P, I've said that whatever you have on the right hand side must be equal to what you have on the left hand side. So what you have here for P, to get P now, when you add these two together, it must be equal to what you have as your P, and that is 84 plus 2. 84 plus 2 give us 86. So the value of P here is also 86. Now let's go for the second equation. For the second equation, we have it that here it is 214 and it's still 214 that is here. So if this is 214 and this is 214, let's get the value of M. Don't forget, whatever you have on the right hand side must be equal to what you have on the left hand side. So to get our M equals this one minus this one, that is 214 minus 214. The value of M is 0. Now if the value of M is 0, that is the atomic mass is 0. Atomic mass is 0. And let's look at the atomic number now. Atomic number. Now let's look at the atomic number. Here you have it to be 84, here you have it to be N. Don't forget, when you add this together, it must give you the 83 that is here. So our N is equal to, what's our N? That is 83 minus 84, and that gives you minus 1. When it does give you minus 1, it means the value of N is minus 1. When the value of N is minus 1, let's determine our X. To determine X is taken to have atomic mass of 0 and atomic number of minus 1. So what is this? This is definitely called beta particle. This is definitely called beta particle. Why is it called beta particle? Because I told you earlier that beta particle is an high energy electron. And don't forget, the atomic number of electron is minus 1 and atomic mass is 0. Atomic number is minus 1 and atomic mass is 0. So that's what you have for this particular question given in WAEC 2014 question 12C. Now we've come to the end of this video, and I believe that at this point you can be able to balance nuclear reaction and also determine the radiation emitted during the nuclear reaction. Now we'll have questions that have been displayed on the screen. Ensure you answer this question and subscribe to this channel if you haven't, as well share these videos with your friends. Thank you for watching. We'll see you next time.